Hello, welcome to another problem session. So this is a problem from IIT JEE contest. The background is that you have two charged particles, one of mass 4 AMU atomic mass unit, another is mass 32 atomic mass units, and they're initially at rest, but then they're going to be accelerated at potential V, and so they're going to pick up some speed, and then they will go into region of uniform magnetic field like this, and so this area is all uniform magnetic field B, and then they're going to make a circular motion. Either it's going to be this way or that way, you know. So let's see which way it's going to be. If the magnetic field was pointed coming at us and the charge is positive, both of them positive charge, then V is that way. So V cross B, if it's going that way, so acceleration is that way. So using right hand rule, this actually will be going that way. V's will be going that way if the B is coming out. And so in a previous video, I showed you how this comes about using mass dV dt equals to Q V cross B. So this leads to this thing in a uniform magnetic field is B is constant, and you can see that you can set it up like B in the z-axis and things like that. So you kind of either need to remember this or need to be able to discover this while doing this problem. So R is for the radius. And another thing that we goes into this problem is this is if I have at rest, and if say this is a over here the potential is zero, and V's speed is 0, and this is potential is 0, over there is potential is V. So say there are two plates here, and it says if they're accelerated through a potential V. So if this is a positive charge, then we'll have this as a V, and V, this will be 0. Okay, so that this is a positive plate and this is a negative plate, and it accelerates, and then this is where the magnetic field will be, B region will be. So over here is going to make a, so if I go like this, it's going to come out like this, and radius R, and there will be different radii for different things depending on this formula, right? So what's this V will be? What's the speed will be? Well, over here is energy conservation. So over here, if charge is Q and potential is V, so energy is at point 1 versus point 2. At point 1 is all potential energy, Q times V. There's no kinetic energy. And at 2, potential is 0, so the potential is 0, and so this is, and this 0 plus half m little v square. So you can see that half mv square going to have to be Q times potential. So that's another thing you need. We need these two, and then we are off to races. Okay, so write down, let's see, using radius. So R for the alpha particle, it's just going to be m of the alpha particle, v of the alpha particle over charge of the alpha particle times magnetic field. It's the same for both of them. And R for the S or sulfur ion is going to be m of the sulfur ion, v of the sulfur ion over Q of the sulfur ion times B. Now if I take a ratio of these two, rs over r alpha? That's the question. What are you going to get? b will cancel out, so this m of s, m of alpha, v of s, v of alpha, and then you're going to have a q of s, q of alpha over q of s. Now we know this combination mv, and maybe it's better to rewrite this like mv square is 2 times qv, and let's multiply with m. So this is m. So m times v, like this combination, is square root of 2qv and m. So we're going to have a 2 qs ms potential that went through to q alpha and square root of this whole thing, m alpha times v, and the v got cancelled out, and q alpha over qs outside, and you can see the 2 got cancelled out, and this is twice as much as that, so this is 2 and this is 1. And then this one, I don't need to go kilogram and things like that, right? This is, I can use any unit and unit will cancel out. So s is 32 and this is 4, and alpha is 2 and this is 1. So square root of 1 times 32 over 2 times 4, this whole thing times 2, and so the square root of 4 times 2 equals to 2 times 2 equals to 4. So that's the answer. It's a really simple question, but you need to be able to recognize that we have this situation, how to get the speed over here, and then you have this situation, how to know this radius here. Once you know those components, it's a matter of working through it and kind of simplifying here so that you don't get bogged down into putting AMU to kilogram and all kinds of unit conversions. That's not necessary here at all. And that's why I think this question is a really good question. Okay. All right. Well, if you like this kind of answer and questions, please subscribe to my channel. If you like this explanation, hit the like button. You want to check out my website, go ahead, go there. I'll see you in another video. Bye.